So in this video, we're going to look at if you were to stand in front of a train and try and slow it down, would that really work, and how much speed would you really take off it? And cartoons aside, really what we're looking here is an example of a momentum question where the masses combined. You'll see what that is in a sec. Right, so let's start off. Same kind of setup as last time, where you have got your mass there, 75, we'll say, which is that's about my mass, I think. So average guy, not too many pies, but he's standing there with v as 0, which means velocity 0, not moving. So he's kind of going, come at me train, go on. I don't know why he's got blue boxing glove there or something. So the train is going at minus 40. It's got about 40 tons of mass. Outlook not looking great for the man, but hey, he's optimistic. You know, positive attitude is accounts for a lot in life. So not mathematically, but psychologically. So we're going to use the same kind of equation. We're going to have the momentum before, and that'll be equal to the momentum afterwards. Now it's going to be strange when the two come at each other here. His head came off there. That's not supposed to happen yet. When the two combine, they're gonna, in this question, kind of stick together. So you can do this with magnets and stuff like that. But basically, what's going to look like afterwards is they're just going to be one mass, and that's okay because we can add. You know, and that looks kind of easy. 75 and 40,000 is 40,075. It's not too bad. Now we don't know, and our target variable for this evening is v2 for the train. So well, the whole thing together really. So we don't know what speed the train will be going afterwards. We know it was going at 40 meters per second, but afterwards we don't know. Will it be like 0? Will he stop the train? Will it be half the speed? Will it be barely any change at all? We will use the momentum equation to find out. Let's do it. So same line starting off again here. It's momentum before, momentum afterwards. You just change that to MVs. Each of these represents a little MV. Man momentum, train momentum. And I've written these down here, all nice and neat. Afterwards, because the mass is kind of combined here, we're just going to say the mass, the man and the train combined, and also his velocity we don't really know. So it's going to be mystery. Nobody knows yet. We will know soon though. Okay. Then what we do is we just sub in the numbers, and that's not really too bad. Alright, let's take it one bit at a time. Well, his mass is 75. He was at 0 starting off. That's this MV done. The train's mass was 40 tons, and its velocity was going right towards him, so minus, as in going towards him, at 40. Then we added them together, the masses, and that's what the number we got, 40,075. And v, we don't know. We don't know what speed he's going at afterwards. Cool. So then you're going to simplify all that together, and you're going to get 1.6 million. So again, we're going to look at we're going to probably have interesting numbers coming out of that when they look this big. But in reality, numbers are that big. The universe has massive numbers, a lot bigger than that. We've got this 40,075 right in front of our v, and we really want to get v by itself here. So I'm probably going to move this over there. I might actually switch the two around when I'm doing that because I like my v to the left. Okay. I have it in this case. I'm just going to leave it like that. So there's my 40,075. It's just come under as a fraction. Really what I'm doing there is dividing both sides by 40,075. That side will cancel out. And now I'm left with this big ugly looking thing, and that is our value for v. You can just simplify that. So plug that into your calculator, 1.6 million divided by 40,075. You'll get a number which is 39.925. And this is one of these great moments because that makes sense. By the way, that should be meters per second because it's a velocity. 39.925 is our answer for V. It was 40, it is now 39.9. So we can say there wasn't much of a change. In fact, it went down in speed by 0.1%. So you may make a difference someday in life, but having a face off of the train is not a good way to do it, mathematically anyway.